Okay, this video picks up right where the last one left off. We are at 3:34 p.m. This is just about an hour, a little over an hour after launch. What I'm going to try to do now is actually rendezvous with the International Space Station. Currently, the ISS is here in the orbital path, represented by this yellow line, and I am here represented by this green line. Before I do any orbital maneuvers to try to rendezvous, I need to get closer to the ISS. And the only way to do that, at least the best way, the most realistic way, is to just orbit the Earth several times until the gap closes. Orbiting around the Earth doesn't require any engine burns, so it's basically free energy to just let the variations between our orbital altitudes do all the work in closing that gap. And I know when STS-129 launched that Monday afternoon, it wasn't until Wednesday morning that they actually rendezvoused. They spent over 24 hours, I guess that'd be closer to 36 hours, just orbiting the planet. So I'm going to do several orbits to catch up to the ISS. I'm going to use time acceleration. And this method may not be real sexy, but like I said, it's free energy. Doesn't cost us anything to orbit the planet. So we'll go around several times here. And it will probably have some effect on the relative inclination, at least it might, when you go around this many times. And speed it up a little bit more. I don't want to get too close. If I get right on top of it, then I won't have enough time to do orbital maneuvers. Let me speed it up a little bit. Get a little closer yet. A little closer yet. And I'm going to say that's about as close as I want to get for now. That should leave me plenty of time to do some orbital maneuvers. It's now Wednesday morning, 5:30 in the morning roughly. So first thing I'm going to do, check my relative inclination. It's still 0. So that's good. Now the next thing I want to do is I got to pick a point where I'm going to rendezvous with the ISS. And the two convenient locations are your apoapsis or your periapsis. It just gives you a nice point at which to rendezvous, although you can rendezvous at any point you like. But I'm going to use my apoapsis. I need to know what the altitude of the ISS is at my apoapsis. And the way I can find that out is by fast forwarding time here a little bit until this yellow line is pointing directly at that green bubble. And I'll pause it here when I get there so you can see what I'm talking about. Okay. Actually, I'll just put it on time acceleration 1 so that I can continue to make changes here. You can see here that this yellow line is pointing directly at that green bubble, and that is my apoapsis, and this green bubble here that's filled in is my periapsis. So what I want to know is what is the altitude of the ISS right now, and it's 374.7, so I'm going to write that down. 374.7, I wrote that down. Now I'm going to go back to real time, and what I need to do is I need to get my apoapsis at 374.7. See, currently my apoapsis is 72.9. So I need to bring it down to 374.7. And with basic orbital mechanics, the way we lower our apoapsis is by doing a retrograde burn at periapsis. So I'm just going to fast forward time until I am at periapsis. I'm 375 seconds away from periapsis. Let me go forward a little bit more. And I'll put the orbiter, the Space Shuttle Atlantis, into the retrograde position. And something I'll do this time, which I forgot to do when I was doing my other burns. The way the shuttle's OMS engines, I believe they're called, the way they're mounted at an angle. So if you do a burn straight on like this, it's actually off center. So you need to set the retrograde autopilot and then turn it off and then pitch up so that this red crosshair is over the retrograde position. Let's do that here in just a second. Get a little closer to periapsis. That's close enough.
Rotation.
Pitch up. And burn. Bringing down my apoapsis. Should have started that burn a little sooner. Since I don't have the autopilot on, I'm using translation thrusters to keep that crosshair set near the retrograde position. Back off the main engines a little bit so I don't overshoot. 380, 379. Close enough. Now we'll use translation. .7. Okay. Now check my relative inclination. It's still 0. Now I'm going to go back around and I'm going to check the altitude of the ISS at my apoapsis one more time, just to make sure that it didn't adjust. Because sometimes when you do these burns, your position, your apoapsis or periapsis, will move forward slightly or backward slightly, and it's usually not a problem, but sometimes it'll move enough that it will actually make it where the ISS would be at a different altitude. So I just like to check that. Plus I have to go around anyway to close the gap. So this is okay to do this. Getting close, and it is basically right there, and it's still 374.7. And if this were off by 0.1 or 0.2, I wouldn't worry about it. This is one of those. Sometimes things have to be exactly lined up, like the relative inclination has to be exactly 0.00. But if there's a slight difference in altitude, you got to remember that last decimal is meters. So if it's 374.6 as an example, well, over here, then that would be 100 meters in difference of altitude, and that would be correctable when we do the rendezvous. But a difference over here of 0.01 is much more problematic and substantial. It's just one of those things that you learn as you're doing these rendezvous. So now what I need to do is close the distance. So I'm going to set up sync orbit MFD. I'm going to give it 18 orbits. I think that's the maximum it'll display. And it shows you how far out in the future you're going to have an orbit that will be the closest to the object that you're trying to rendezvous with. And there are several points of reference. SH apoapsis means ship's apoapsis, and the ship is me. I could also do target, TG, that's target, and target periapsis, which would be the ISS is the target. So I could rendezvous at the target's periapsis, I could rendezvous at the target's apoapsis, or I could rendezvous at the ship's periapsis, which would be over here, or the ship's apoapsis, which is what I've chosen, which is here. And there's other ways to rendezvous as well, but this is just the method that I'm most familiar with. So I need to close this down to 0.00. The DT min, off the top of my head, I can't remember exactly what it stands for, but it's basically the difference in time between me and my target at the rendezvous point. So at the rendezvous point, my apoapsis is what I want it to be. I'm at the same altitude as the ISS is at this point in orbit, but we're separated by 29.91. I don't know, I think that's actually seconds. Not sure why it's called DT min. Maybe it means minimum distance or minimum whatever, but that's way too much. With as fast as things are moving in orbit, being off by even a fraction of a second is a matter of, hundreds and hundreds of meters. So being off by this much is probably a distance of, several kilometers. I don't know exactly what it would be. So to bring this down to 0, I need to go around to my periapsis, because I don't want to make, actually I'm sorry, I need to go around to my apoapsis, because I don't want to make any more changes that will affect my apoapsis. So if I made any burns at periapsis or anywhere else in the orbit, it would affect my apoapsis, and I don't want that to happen. So I need to go around and make a burn at my apoapsis that will bring this down to 0. So I'm going to do that now. ISS. And the only way to do that, at least the best way, the most realistic way, is to just orbit the Earth several times until the gap closes. Orbiting around the Earth doesn't require any engine burns, so it's basically free energy to just let the variations between our orbital altitudes do all the work and close. What I'm going to try to do now is actually rendezvous with the International Space Station. Currently, the ISS is here in the orbital path. Okay, this video picks up right where the last one left off. We are at 3:34 p.m. This is just about an hour, a little over an hour after launch. It's represented by this yellow line. And I am here, represented by this green line. Before I do any orbital maneuvers to try to rendezvous, I need to get closer to the